Hi, Algebra 1 students. Today's Wednesday, April 1st, and it's no joke, we're going to have to do all our work today, even though it's April Fool's. I want to start us with a prayer. Father in heaven, we just thank you for this day. I just pray so much for all my students that you would help them to focus and learn well, even though we're right on the brink of vacation. And I pray for myself that you would help me to be the very best teacher I can be, using words that will give them the greatest understanding. And I pray that they would master all this material and do great on their test. Thank you that you're with us and you're faithful. In Jesus' name, amen. Okay, well, we have an exciting day today. We're only going to do one lesson. It will be lesson 11.5, and that is the midpoint and distance formulas. And when we're done with that, then we'll go outside and see what happens with our Zipline and Barbie, and if she lives or not. So anyway, I'm going to sit down and use the overhead, and you guys can take some notes. Okay, there we go. There's our screen. Like I said, this is lesson 11.5 for Algebra 1, and it is the distance formula and the midpoint formula. Now, they really aren't very hard. The distance formula just has a lot of letters in it, and all you do is substitute the letters and come up with the answer. That's all you do. So the distance formula for 1 point, this is point 1, to our second point, so here's point 1, and we call that x1, y1. Point 1 has a 1 for a sub number on each one, to point 2, and that's x2, y2, okay? So we're going to use x1, y1 and x2, y2 in our formula, but all they refer to is the 2 points that we're trying to find the distance between them. So here's our formula. It is the square root of x squared minus, or x, sorry, not x squared, don't do that. x2 minus x1 plus y2 minus y1 squared, okay? So like I said, in this formula, there's a lot of variables, and all you do is put the numbers in and come up with an answer. And it's based on the Pythagorean theorem, so it's all in the same family. So here's number 1. Let's do an example. Find the distance. Why does that say search there? Find, well, we have a little search there. Anyway, find the distance. Nicole, are you there, dear?
Yes.
Can you go ask Johnny to turn his music down, please? We still are in this house making noise. So the music is making noise right now. Find the distance between -1, 3 and 5, 2. So those are our 2 points. Okay, so I'm going to name them. And this is x1, y1, and this is x2, y2. I always name them because it's so easy to get it mixed up. Same with slope, as you've seen. It's just too easy to drop negatives or whatever. Just label them that way. So my distance is going to be the square root of, now let's go back up to our formula. What have we got? Oh, it's way up there. x2 minus x1. So x2 is 5. We can see that. Minus x1. Now be careful. I've got a double negative there. So I have a minus in my formula, and I have right here a -1. Don't drop that. Okay, and then y2, which is 2, minus y1, which is 3. Okay, so let's figure that out, and I get, when I have a double negative here, that becomes positive. See why that's important? You can't drop that negative. Otherwise, you would end up subtracting. All right, so I have 6 squared, and it would change our answer. 2 minus 3, cross the line, change the sign, and I have negative 1 squared. Let's go over this way. So I get 6 squared is 36, and negative 1 squared is 1. So I get an answer of the square root of 37. Now, if you have that, that's totally fine on a test with me, but when you're checking your work, you might need to have a decimal for the answers in the back of the book. And if you do, then that comes out to be approximately 6.08. Okay, so really it's not very hard. You just have to go slow and be careful so that you put your negatives in and substitute correctly. All right, so here's number 2. Now this time, we're going to find the distance between 3 and negative 5 and 7 and C. So the distance between 3, negative 5 and 7C is 5 units. Okay, find the value of C. So this is a little different this time. Now remember, I'm going kind of fast. So use the video as you like. Pause it, rewind it, custom use it so that it helps you learn best. Okay, so this time I know the distance, but I don't know the value of my second point there for y. So I'm going to write my formula. I just want to have it right there to see x2 minus x1. And we're going to see how this works. Now I have 5 is the distance, and I already know that. So then I'm going to have the square root of, and I'm still going to substitute everything in and see how it works out. So let's see. Now I always write x1, y1 here, and x2, y2, so I don't forget. So x2 in this case is 7, and x1, that's kind of hard to read, is 3. And then I have y2 is my c, and y1, be careful, is negative 5. So again, I have to be careful of those negatives. All right, so let's keep going. 7 minus 3 is 4. And I'm going to have a double negative here, so I end up with c plus 5 squared. Okay, so let's keep going. I'm going to have 4 squared. Hey, you guys, cut it out. 16. Now I have c plus 5 squared, and that means c plus 5 times c plus 5. So I'm going to have to use FOIL to figure all of those out. Don't just get stuck here. We have the tools to solve this. We learned them in chapter 9. So let's just keep going with it. So I'm going to use FOIL, which is c times c. C times 5 is 5c. 5 times c. So here, this is first, outside, inside, and then last. Okay? So those are my terms. So now I can add the middle terms. Okay? So now I'm going to put that in here. Because if I want to work this out, I have to put my worked out answer inside here. Okay, so then I have the square root. Now I'm going to add whoops, add 16 and 25. Okay, now I'm here. Now the problem is I have all of my letters under the square root. So I have to get rid of that square root. How do I do that? I learned that in either earlier this chapter or in chapter 10. So I'm going to square both sides. And I get 25. Now my square root is gone because the power of 2 cancels that. And I'm going to solve this. Now this should look familiar. I'm going to subtract 25 and I get 0. This is certainly something we've done before, and this becomes plus 16. So now I want to solve for C. How do I do that? That's a trinomial. We've seen that factoring before. I'm going to use magic X. So what multiplies to be 16 and adds to be 10? Well, if I list all my factors of 16, what do I get? I get 2 and 8. So I've got 0 equals C plus 2 times C plus 8. And now I'm going to set them equal to each other. And I subtract 2 and get negative 2. And I subtract 8 and I get negative 8. Now, you might be thinking, well, wait a minute, it's the distance formula. I can't have a negative distance. And that is very true. However, I'm not trying to find the distance here. I already have my distance. It's 5. What I'm trying to find is the value of the y coordinate that will give me that. Now, if we graphed these, let's see what we would have, and you would see it. The first point was 3, negative 5. So where's that? 1, 2, 3, and then 1, 2, 3, 4, 5. So that's down here. Now the other point was 7C. So I've got 7, and I'm going to put C in, and I'm going to put negative 2 in, or negative 8. Okay, so 7, negative 2. 1, 2, 3, 4, 5, 6, 7, 8, negative 7. I'm going to come down. So 1, 2, 3, 4, 5, 6, 7, negative 2, and 7, negative 8. So 1, 2, 3, 4, 5. Going to extend this. 6, 7, 8. So that's down here. So do you see what I have? My graph is a little off. This distance is 5, and this distance is 5. So I have two different answers that both work to give me the distance of 5. There are 2 points that are exactly 5 units away from 3, negative 5. Do you see that? So that's why I have 2 answers. Okay, what I want you to do is the OIOs. So number 1, find the distance between 3, 0, and 3, 6. So go ahead and figure that out. And then number 2, the distance between 1A and 4, 2 is 3 units. Okay, so go ahead and pause the video and try those 2, and then we'll come back in a few minutes. All right, so let's do number 1. I'm going to move this over here so I'm away from this. Okay, my distance formula is D equals the square root of, now I'm going to label my points, x2, y2. So I have 3 minus 3 squared plus 6 minus 0 squared. So this becomes 0, and 6 squared is 36. So I have the square root of 36, which is 6 units. So my distance between these 2 points, 3, 0 and 3, 6, is 6 units. All right, number 2. I'm going to have D equals, I'm going to just write my formula, x2 minus x1 squared plus y2 minus y1 squared. Okay, and I know my distance here is 3. So then I'm going to have, I'm going to label this again. All right, so x2 is 4, x1 is 1, and then 2 minus a squared. Okay, here we go. I'm going to do it quickly because I assume that you've already tried this. All right. So I've got 3 equals the square root of 9 plus, now if I work this out, I get 4, let's see, 2 minus a, 2 minus a, I get 4 minus 2a plus a squared. So I get 4 minus 4a plus a squared. So now I'm going to add 13 minus 4a plus a squared. Okay, now this, we haven't seen it in this order. Let's change it to standard form. It's a positive a squared. It won't change anything. So I can just, I can just do that. So now I want to get it out from under the square root. So I've got 9 equals a squared minus 4a plus 13. Subtract 9. 0 equals a squared minus 4a plus 4. Oh, doesn't that work out well? Now I have magic x. What multiplies to be 4 and adds to be negative 4? Negative 2 and negative 2. A minus 2, a minus 2. I only need to set one equal to 0 because they're the same, and I get a equals 2. So there's 1 point between, to find the distance, that's 3, and that would be 1, 2 is the point, and a is 2. All right, we're going to keep going now. And let's do the next part of our lesson. So I have the midpoint formula. Okay, when I want to find the midpoint, well, what's that? If I have a line, and here's A and here's B, and it's diagonal especially, that's hard to find. I want to find the point that's in the middle. That is the midpoint right there. So my formula in the middle is going to be x1 plus x2 over 2 and comma y1 plus y2 over 2. I'll give you a minute to write that down. Now this makes sense, because what I'm doing is I'm adding the two values of the x-coordinate together, and I'm averaging them by dividing by 2. And then I do the same thing over here with the y value. I take the two y values of my points, I add them together, and then I average them, finding the middle, average is always in the middle, by dividing by 2. Okay, so all I have to do if I have my points is substitute them in. So let's do an example. This is number 3. What is the midpoint of the line segment with endpoints -1, 2, oops, I'm sorry, -1, -2, and 3, -4. Okay, what's the midpoint? So I'm going to have my formula, x1, x2, whoops, sorry about that, and y1, y2 over 2. All I'm going to do is put the numbers in. So I'm going to label this. I'm going to change colors really fast. So let's see, x1, y1, x2, y2. Okay, so x1 is -1, x2 is 3 over 2. Then y1 is -2, and y2 is -4. Okay. So I just have to simplify. -1 plus 3 is 2. -2 and -4 is -6. Okay. Let's just keep simplifying. All of a sudden, it becomes just a point. So 1, -3 is the midpoint. Okay. Just one moment there. All right. What I want you to do is an OYO for find the midpoint of 4, 3, and 2, 5. Okay, I will give you a minute to use that formula to figure it out, and then we'll be finished. All right, let's go over this together. I'm going to switch back to blue, and we're going to figure it out. My midpoint formula is x1 plus x2 over 2, y1 plus y2 over 2. Okay, so let's label. Okay, so I have 4 plus 2 over 2, and I have, sorry, this is, oh, yeah, that's right, okay. Y1 is 3, and Y2 is 5. So I get 6 over 2 and 8 over 2, and that becomes 3 over 4. So the midpoint of those 2 points is 3 over 4. Okay, we're done with our lesson. And now we're going to talk about Barbie and whether she is going to survive our zip line. So here we go. I hope you had a chance to have some fun and create your own zip line at home. And I would love to hear from you if you have a short video or a message you could send me and let me know. I could see it maybe, and let me know how it went and what length you think is best for the height of the zip line that you are creating. Because of course, we don't want to use human beings because you can die. It's too dangerous. So we use Barbie to see what we can come up with. So I'm going to call my daughters now. Danielle and Nicole, would you come help me, please?
Yeah.
And we're going to go outside.
I'm going upstairs.
One daughter is going upstairs right now with Woody and Ariel to see them come down the zip line. Might want to put that down. Okay. Come on outside. Excuse the mess. One daughter's moving back in from college.
Can't even see it. You're fine.
Oh, okay. Well, we just have a lot of stuff here. Okay, Nicole, can you find Woody? You might want to open the shades there.
No, it's not for you. Leave it.
Okay, just to review what we're looking at here. Hi, neighbors. Is that we have
Oh, I'm so sorry.
We have the dogs barking. That's what we have.
No,
Okay.
Rosie,
Hey,
Rosie.
Get inside. Get inside. Go inside, you silly dog.
Good.
Always gonna go laugh out of this.
Sorry. How do I zoom out on this thing, Mom?
So let's review. We've got 12 feet from the top of the balcony, and we're gonna send, I guess, Woody's first. He still
No,
looks
Barbie,
unexcited. You can come close. Danielle, you'll be too far, dear.
No, I'm barely getting the whole shot in.
No, but we
I
can't
don't want
hear
you
you.
to see the whole thing.
Oh.
So come closer. You'll just have to follow. You can stop. Follow Ariel coming down. So
Okay.
the first thing we're gonna do is stretch
Really
our
can't see anything.
zip line to 5 feet. Now, what we're gonna do is Nicole's gonna send Ariel, and I'm gonna catch her down here, and we'll see how it feels. It's kind of a judgment call. Do I think that she would be damaged or harmed if she landed at this speed? So we'll see about this steepness. Go ahead.
Help me out.
Woo! Ow! Well, she crashed. I guarantee that hurt. Let's try it again with Woody. Have you got Woody?
Yeah, I do.
At the 5 feet.
Is that a Jasmine? Poor Jasmine.
Okay, and mark is at go! Woo! Ow, that kind of hurt a little. Okay, let's try it again. So I'm going to toss these up to you. Whoop,
Nice.
There's Woody. And here's Ariel. Oh, Jasmine. Keep playing the color. A little collateral damage there. We're sending her to the hospital. Although, yeah, anyway. Okay, here we go. All right, now we're going to do 10 feet. So here we have 10
this will be
feet.
better.
Okay, I hope you're trying this. Now that's 10 feet from the perpendicular distance down from the balcony. So let's see. Woohoo!
I live
Let's
life
see.
on the edge.
Woohoo! Now that's definitely slow.
We have 4 dogs.
Okay. Want to send Woody down?
Yep.
Okay. Now Woody's a little heavier, so he tends to get hurt a little more.
Hi, guys.
Okay, so let's try it again. You ready? Whoa! You caught her! Can't believe it. You ready? Whoa!
Clearly, she doesn't have an arm.
Plastic surgery. Wah, wah. Okay.
Plastic
Okay, so let's try all the way out here to 25 feet is a lot longer, isn't it? Okay,
Barbie's
let's see
very
her
excited
come
about
down.
this one.
Let's go.
Yeah.
Woohoo! I don't know. I think it seems kind of slow. Send Woody too. He's definitely a little faster. So probably the 15 foot is better. Now just for fun, let's see what 2 feet would be like in case you did that. So we'll send just, whoa, Jasmine, I can't believe you caught her. Okay, so way down here. Let's see if she lives or dies.
I don't even think she'll stay on the string. I don't know if I can get Barbie on the string.
Go. Oh, well, definitely that was a bad idea. She's going to the hospital. This is more like bungee jumping. Okay. Well, I hope you've seen. Now, we could use an experiment like this to find out what length of a zip line would be fun and yet safe. And we use the Pythagorean theorem to figure out how much zipline we need. Now that may not sound like a big deal, but when we saw that video of the Sasquatch, do you know how long that cable was? That was one cable. It really does matter whether the cable is 2,000 or 3,000 feet long, or 1,500 feet long, or 5,000 feet long. It's a much different thing. So anyway, I hope you had fun experimenting and playing around with Barbie, and I hope you have a great Easter vacation, and I will be enjoying it with my family, praying for you, and have a great week. Bye now.
Thank you.